Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about I/O interfaces. How that input-output devices will be connected to the microprocessor. So an I/O interface is a crucial component that will be facilitate as a given chance to interface an external devices to the microprocessors. So peripherals like sensors, actuators, switches, LEDs, display devices that will be connected to the microprocessor through this I/O interfaces. Look at this simple example. Here we are connecting an switches. Look at this S0, S1, S2, S3. So these are the switches. So this is the pull-up resistors and this is a tri-state buffer. So from this we have the data bus. So we need to have an address for this. Look at this. This is an address decoder. So here we are connecting this A7 directly to ground, and then next three lines, that is A6, A5, A4, that will be connected through OR gate, and then A3, A2 that will be connected to ground, and then A2 C, and then A1 is B, and A0 is for A. So this decides one particular address. So this address will be taken. And look at this memory and I/O operation with this read operation will be combined. Once combined, we get an I/O read operation. So this also combined with this enable signal and given to the output enable or a chip enable signals. So only whenever this particular address is given, so this chip is enabled. So once this chip is enabled, so depending upon the switch, the data is read and connected to the data bus. Look at this. Why we use pull-up resistor means, so it should not have an high impedance chip. For example, you look at this. If the switches are open, what happens? It is an open circuit. So no signal will be present here. We cannot read it whether it is a logic 1 or logic 0. So to avoid that only we are using this pull-up resistor. So due to this pull-up resistor, if the switches are open, so the 5 voltage is connected to that particular lines through this resistors. So whenever the switches is open, that logic 1 will be present in all the switches, because this 5 volt is connected to this resistor. So this will be logic 1 for all the 8 lines. Whenever we press that particular switches, for example, if I press this S0, so once if I press S0, so this ground will be connected to this 0th line. So what happens? So here it will be 0 will be read. Even though the pull-up resistor is connected, so 5 voltage will be connected, that 5 voltage will be across this resistor, and then logic 0 will be read here. Similarly, whichever the switches is closed, so that places it reads a 0, remaining all places it will be read as a 1. So to avoid high impedance state, we are making this pull-up resistor. So the corresponding value that will be read as an 8-bit inputs. Look at this. So this is also similar configuration. Here we are taking it's a 2 ports. So these have another address and these have another address. So whenever we give them particular address for this, so this chip enabled and these keys are readed. If we give an address for this chip, so these I/Os will be readed and that will be connected to the data bus. So multiple I/O devices can be interfaced. Look at this output device. So look at this. This is then one LED. Similarly, we have an 8 LEDs. So LEDs have a 2 terminals. One is anode and another one is cathode. So we no need to connect both anode and cathode to be controlled. Simply we need to control one is cathode or anode. So here we are using this common anode configuration. So common anode configuration means all the anodes of the 8 LEDs will be connected and that given to the 5 voltage power supply. Once if you give a supply to cathode, the LEDs will be closed. So for a cathode we need to give a 0. Once if we give a 0, that LEDs will be closed. So we have an port 8 bits. So 8 bits we give some values. Depending upon that, what are the values 0, that LEDs will be closed. What are the port values have an 1, that LEDs will be off state. Look at this how it will be decoded. So we have the decoders. So ABC will be connected to A0, A1, A2, and then A3 will be connected to ground 1, A4, A5, A6 that will be connected through OR gate to the G2 bar, and then A7 that will be connected to the ground. Look at this. This is we have output. We have this Y0, Y1, Y2 up to Y7. Here we taken as a Y2. So if you took taken Y2 means this ABC must be a 0, 1, 0. So if you take a Y0, it should be 0, 0, 0. If you take an Y7, it should be a 1, 1, 1. So 0, 0, that is Y0 to Y7, that will be selected from the ABC lines 000 to 777. Look at this, these line will be combined here. Memory bar write bar signal combined, we get an I/O write command. So from this we get combine this signal and given to the chip enable. Look at this actual LEDs. This is the data bus will be connected. So if your data bus you have an 8 bit, so 8 bit what are the bits will be 0, that LEDs will be closed. Remaining what are the LEDs, that is value will be 1, that LEDs will be off state. So because here we are using this common anode. Similarly, if we can use a common cathode, so if we use a common cathode means all the cathodes will be connected and that will be ground. Wherever we give an anode supply, that LEDs will glows. Look at this, two ports will be connected here. So here one port and this is another port. So these two will be connected. So we get an this is 8 bit and this is 8 bit. Totally 16 bit data will be, we can get it. Look at the I/O interfaces. So here we have a combination of both input. So this is then 8 inputs and this is 8 outputs. So this will be connected to the data bus. Look at this. Memory read and memory write will be connected. I am using this Y0 and Y2. So this is Y0 will be used for this and Y2 will be used for this. So this one port and this is another port. That means one port is an input port and another port is an output port. So that will be connected. So this port will be having 8 LEDs and this port will have 8 switches. So this value will be read and processed and this value can be output. Thank you.